Hello everyone, myself Heli Mehta, working as an assistant professor in computer engineering department at Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. Our subject is computer network. Our unit is 4, network layer. Routing protocols. As I have explained, the routing protocols are two types, interdomain and intradomain. Okay, in interdomain we have a path vector, for that we have a BGP. Okay, in intradomain we have a distance vector, for that we have a RIP, and in intradomain another is link state, and for that we have a OSPF. So in this lecture I will explain about link state, and in next lecture I will explain about OSPF. Okay, so what is link state routing? The link state routing is the second major class of intradomain routing protocol. Okay, so first is distance vector and second is link state. Okay, it is dynamic type routing algorithm. Link state routing is a technique in which each router shares the knowledge of its neighborhood with every other router in the network. Okay, so we have a multiple routers, and router have a their neighbors. Okay, so in link state routing with technique in which each router shares the knowledge of the neighborhood with every other routers in the network. The idea behind link state is simple and can be stated as 5 parts. Okay, each router must do the following. Okay, so each and every router have to follow these. So first is learning about the neighbors. Okay, so every router must know about their neighbors. Measuring line cost, building link state packets, distributing the link state packets, and computing the new routes. Okay, so these 5 they have to perform. Okay, so first is learning about the neighbors. When a router is booted, it sends a special hello packet on each point to point line. Okay, suppose we have a node A, and with node A we have a node B and node C. So node B and node C are the neighbor of node A. Okay, so router A, okay, is send a hello packet to on each point to point lines. Okay, so they send hello packet to node B and node C. The router on the other end is expected to send back a reply telling who is it. Okay, when 2 or more routers are connected by a LAN, the LAN can be molded as a node. Okay, so this is the learning about the neighbors. The router must know about their neighbors. Second is measuring line cost. To determine the cost for a line, the router send a special echo packet over the line that the other side is required to send back immediately. Suppose node A send the echo packet to node B, then node B immediately send back that message. So to determine the cost for the line, the router send a special echo packet over the line that the other side is required to send back immediately. So if A send the echo packet to node B, then node B send immediately back. Okay, so by measuring the round trip time, the dividing it by 2, the sending router can get the reasonable estimate of the delay. Okay, so according to that measure the line cost. Okay, so building line state packets. So third is building line state packets. Okay, so state packets may be built periodically or when some significant event occurs, such a line or neighbor going down or coming back up again. Okay, so they send packet periodically. Distributing the link state packet, distributing the line state packets, each state packet contains a sequence number that is incremented for each new packet sent. Okay, so every packet have a sequence number. Okay, according to that they are sending, and when one packet is sent, they are each state packet contains a sequence number that is incremented for each new packet. Okay, so when a new packet is arrive, it is increment by 1. Okay, so one packet is sent, then next sequence number is 2 for the new packet. Okay, so routers keep track of all the pair they see. Okay, router have all information. When a new link state packet comes in, it is checked against the list of the packet already seen. Okay, so suppose a router have a list of packets, that is 6 packets. Okay, so sequence according to this statement, sequence number are 1 2 3 4 5 6. Now next packet is arrive, new packet is arrive, then it check again the list of the packets. Okay, if it is new, it is forwarded on all lines except the one it arrived in. Okay, so if it is a new packet, then it is transferred to all other routers. Okay, if it is duplicated, it is discarded. So duplicated packets are always discarded. If a packet with a sequence number lower than the highest one seen so far ever arrives, it is rejected as a being absolute. Okay, so if sequence number is lower than the highest one, then this packet is also discarded. Then next is computing the new routes. Once a route has accumulated a full set of linked state packet, it can construct the entire subnet graph. Then Dijkstra can be run locally to construct the shortest path to all possible destinations. So we have a multiple routers, and for that we to transfer the packets we have multiple paths. Okay, so the Dijkstra algorithm can be run locally to construct the shortest path to the destination. So we have to calculate the shortest path from source to destinations. For that Dijkstra algorithm is use. This Dijkstra algorithm I will explain in next lecture. Thank you.